Okay, last week we learned about using the law of sines to find the measures of missing sides and angles on a triangle, on any kind of triangle. Unfortunately, there are going to be situations where we just don't have the information we need to be able to use law of sines. So the good news here is that we also have a law of cosines that we can use when those situations arise where law of sines won't apply. Now, what they've got here, I cut and pasted this from a textbook. So what they've got here looks very complicated because they have three different equations, a different equation for each side of the triangle. So what I want to tell you is you really only need the first one. Ignore these bottom two. When you do like Pythagorean theorem, do a squared plus b squared equals c squared. You're dealing with a right triangle, and it's very important that the hypotenuse is c and that your legs are a and b. But when we're doing law of cosines, it doesn't matter what side is a, what side is b, what side is c. It's going to work the same regardless. So here's how it works. You have the side you're looking for. That number, that side squared, is equal to the sum of the other two sides. So if you were using a, it would be the sum of b squared and c squared minus 2 times the lengths of those other two sides, so minus 2bc, times cosine of the opposite angle. So if we're looking for the measurement of side A, then the things we need to know are we need to know the length of C and the length of B, the two other sides. We also need to know the measurement of angle A. If we have those three things, we can use law of cosines. And again, this is a situation where a law of sines wouldn't help us. But law of cosines will. So let's look at some examples here. Here's the first one. We've got 17 and 28 are two sides of the triangle we know. We're trying to find the third side. And the piece of information that's really going to help us do that is this 114-degree angle. So we're going to set this up. We're going to say x is the side we're looking for. So x squared equals. Now I'm going to take the other two sides of the triangle. I'm going to square each of those and add them together. So 17 squared plus 28 squared. So right now this looks like a lot like Pythagorean theorem, but obviously we don't have a right triangle here. This is a little more complicated. And we have this last piece. We have minus 2 times 17 times 28 2 times each of those other side lengths times the cosine of the opposite angle. So if we're looking for side x, the opposite angle is the 114. I'm going to have to squeeze that in there. So times the cosine of 114. So now it's just a matter of plugging all this into a calculator and getting your value. So x squared equals 17 squared is 289. 28 squared is 784. Minus 2 times 17 times 28. And I will admit I put this all in the calculator together here. But if you take 2 times 17 times 28 times the cosine of 114, you put that all in a calculator. Make sure your calculator is set to degrees. That's going to be important. You will get negative 387 approximately. Again, it says round to the nearest whole number. That is slightly rounded. Notice you can get negative cosines. There's nothing wrong with that. That will happen sometimes. So you do get a negative number that you're subtracting here. So now we're going to simplify this a little bit more. If you take 289 plus 784 minus negative 387, which becomes plus 387, you get 1,460. So then your final step here is just to take the square root of both sides. And you get approximately, I'm using the squiggles to say this is approximate, this has been rounded off. Rounded to the nearest whole number, you get approximately 38. Now, again, we always want to check and make sure these answers make sense. So This 114 is an obtuse angle, which means it has to be the largest angle in the triangle. One thing you learn back in geometry is that the longest side is always across from the largest angle. So x is going to have to be the longest side of the triangle. And if x is 38 or approximately 38, that fits. It's longer than 28. It's longer than 17. Let's go ahead and look at another one. And in this one, we have a missing angle. So we need to figure out how many degrees approximately x is. Again, we're rounding to the nearest degree. And so what we need to do is if we're trying to find this angle, the side we need to start with, that we need to base everything off of, is the side that is opposite it. So the 16. So what I'm going to do is I'm going to take 16 squared. 16 would be like the A, equals. I've got my other two sides, 8 squared plus 22 squared, minus 2 times those two sides, 8 and 22, times cosine of this angle that I'm looking for. So I'm just going to say cosine of x. So that's how I'm going to set it up. And that gives me something I can use to solve for x. So now I'm just going to go ahead and square everything. So we get 256 equals 64 plus 484. And then when you take 2 times 8 times 22, that's 352 times the cosine of x. So now I'm just going to simplify this a little bit more. This ends up being 548. I'm going to subtract the 548 from both sides. What I end up with here is negative 292. When I subtract that, cancel that out, I have negative 342 cosine of x. So I want to get cosine of x by itself, because then I can do an inverse cosine and figure out what x is. So I'm going to divide by this negative 342. The nice thing is that's going to cancel out my negatives. I will get approximately 0.8295. You can round that off as you would like, is equal to the cosine of x. I'm going to go ahead and switch over to the calculator to work this out. So, and what I'm going to do is I'm going to actually divide those numbers again to get an exact number. So we had negative 292 divided by negative 352. And that gave me, again, approximately 0.8295. What I want to make sure is I need to make sure my calculator is set on degrees. So we have this button here that switches back and forth from radians to degrees. If you're using the Google calculator, make sure degrees is in black. Then I want to use my inverses. So I have this number right here is equal to cosine of x. So to figure out what x is, I need to do an inverse cosine. So I'm going to hit my inverse button and bring up inverse cosine. And remember, inverse cosine, another name for that is arc cosine. And I could type in this 0.8295 number, or I can just hit answer and it'll pull that number up again. And I'm going to take the inverse cosine of that number, and it gives, there we go. And it gives me 33.9479, etc., which is approximately, if I round to the nearest degree, that is approximately 34 degrees. So x is approximately 34 degrees. And again, make sure you get a number that's reasonable. If you get a negative answer, you've done something wrong. On a triangle, you're not going to have a negative degree measure. If you get something bigger than 180, you've also done something wrong. All right. One more. Here's a word problem. It says 2 roads diverge at a 75-degree angle. So the idea is somewhere those roads intersect, and then they go in different directions at, that's probably a little too big for 75 degrees, but we'll go with it. 75-degree angle. Two cars, one green and one yellow, meet at the intersection at 11 o'clock. The green car travels down one road. Let's say that the green car is on this road. So this is the green car on this road at 60 miles per hour. The yellow car goes down the other road. So we'll say the yellow car is right here at 40 miles per hour. How far apart will they be at 11:15? So they start at 11 o'clock. That's where they diverge from each other. And 15 minutes later, how far apart will they be? So you got to do a little basic math with the miles per hour here. If the green car is going 60 miles per hour, 15 minutes, that's a fourth of an hour. So if you're going 60 miles in an hour, after 15 minutes, 60 divided by 4 is 15. You would expect to go 15 miles. So the green car goes 15 miles. The yellow car is going 40 miles an hour. If you go 40 miles in an hour, in a quarter of an hour, you would go 10 miles. So the yellow car goes 10 miles. So that's our triangle now. We have a 75-degree angle where the roads diverge from each other. The green car is going to travel 15 miles. The yellow car is going to travel 10 miles. And we want to figure out after that happens, after these 15 minutes have passed and they've gone that far, how far apart are they? What's this distance right here? We'll call that x. So we're going to use law of cosines. So we're going to say x squared equals, we have 15, so 15 squared. We have 10 squared minus, then we got this big thing on the end, 2 times 15 times 10 times the cosine of the opposite angle, which is that 75. So 2 times 10 times 15 times cosine of 75. Let's work this out. So x squared equals 15 squared is 225. 10 squared is 100. 2 times 15 times 10. 15 times 10 is 150. Times 2 is 300. So 300 cosine of 75. We can simplify a little more. Add those two numbers together. 300 times the cosine of 75. When you work that all out, it's approximately 77.6-ish. And then when we simplify that and subtract, it's going to be 247.4. Again, that's approximated. You can get a better approximation on your calculator. So I have x squared is equal to about 247.4. So my final step, because I don't want x squared, I want x, is to take a square root of both sides. So take my square root of x squared, take my square root of this 247.4. And when I do that, I will get that x is approximately 15.7. I want this to the nearest tenth of a mile. And when I plugged it in my calculator, that's the nearest tenth of a mile is 15.7. So they are 15.7 miles apart. So that is law of cosines. It looks a little weird, looks a little cumbersome, but it's really just plugging a bunch of stuff in the calculator. Just make sure you don't forget any of the pieces. Make sure you've got the two sides squared and added together, and then make sure you have the -2 times the two sides, and then make sure you have the cosine of the opposite